going to put some cosmetic holes in this around the inside of the web here, around the web anyway. I've decided to make them 1/2 inch, like this flywheel, but I'm going to put 8 in instead of 4. This distance I've measured at 2.238 inches, more or less. And if the holes are 1/2 inch diameter and I want them as far out as I can get them, minus 100 thousandths. I'm going to give them 100 thousandths between the edge of the hole and the rim here. So that gives me a bolt hole circle of 1.638 inches, which means I need to put a hole every 45 degrees. So as a test, I'm going to mark a few of them with my super accurate setup here. I've got to offset the table half the diameter of the bolt hole circle. Remember, the bolt hole circle is 1.638 inches, so I'm going to offset half of that, or 0.819 inches. So I'm going to do that now. Doesn't make any difference what direction you offset it. There's 0.8. Thousandths. I'll get this on a place I'm going to start. I always like to start on 0, and of course I passed it up. Passed it up again. Let's go back this way. Nope, let's go around this way. It's kind of important to pay attention to what the hell you're doing. Alright, put a mark there, and then go around 45 degrees. I'll be back. Every 15 degrees turns out to be 11 full turns of my crank and a quarter of a turn. So I just did that. There's the next hole. I'll do another 11 and 15. Actually, that's enough. I don't have to do another 11 and 15. That's enough for me to see what I want to see with this. I used a bolt hole circle calculator from Little Machine Shop just to make sure I wasn't insane on this. Here's the column of numbers I'll be using. If you were laying it out in XY coordinates, you'd use the XY coordinates shown in these two columns. I'm going to use 3 bits on the way to 1/2 inch. I'm going to step drill it. Even though this is aluminum, I'd like to have a nice finish, and step drilling gives me a nice finish. So here we go. We got the table locked down for the first hole. I've got the mill turning at 1960 RPM, which is 256 SFM. And I've got it up that high because it'll allow me to just get this drill this half-inch bit in. Show you one hole, and then I'll bring you back when it's finished. That went through nicely. So that's what it's going to look like. There it is. I like it a lot better with 8 holes in it than I did with 4. I'll deburr them a little bit. Call it good. Well, I'll have to stick a set screw in there. Then call it good. All's well. No, not really. I'm dissatisfied with it. I build these engines to run on 2 pounds or less, and this one's taking about 8 pounds. And I haven't built the base yet, but that's not important right now. And I think the problem is the valve. See how see the airflow there? That's the valve closed. The air should not be coming out here. It should be all directed into the cylinder. If you remember, kind of a nice whistle, isn't it? I turned that, not turned, but I ream that valve a quarter over. .250 inch over reamer, which is what? I don't know what it is. 5/10 over. I think what I should have done is made it a quarter inch and then taken a piece of quarter inch drill rod and polished it to fit. I think that's what I did in my previous engine. Can't remember. In any case, there should not be that much air escaping around that valve when it's supposed to be closed. So I believe the fix is going to be to return the valve itself, the little section of drill rod itself. I'll have to make it from something larger than a quarter inch and turn it down to fit the valve body. It's easier said than done. I think that's going to be the fix. Because I want it to run on 2 pounds of air would be nice. 3 pounds the most. We'll see.